Okay. So we got 3 classes left. The thing to think about now is hopefully you guys have all handed in the web homework that was due on Tuesday. I'll grade that this weekend and get it back to you. I haven't heard back from the registrar about when my last moment of grading stuff for the final is. As soon as I hear from them, I'll let you know what the final due date is, like the take-home final and stuff like that is. You'll officially get the take-home final next week. I'll probably post it on Monday to Blackboard. So hopefully you guys have been playing around with the Scratch program. Um, any questions on that or on the lab or anything? Nope. Okay. Well, I do want to spend. Well, we'll see how long this takes. I want to spend a little bit of time going over some of the more advanced things in Scratch, just so you've seen them, so you can do the homework. And then if I have time, I'll start kind of next week's stuff a little bit early, just to make sure we have the right background on that. So this is my Scratch stuff page. A couple of things I want to walk you through. Let me see if I can find it. Let me do the add the variable thing, because that is sometimes something people mess up. So where's my arrow move program? This is one of them. So assuming this loads, come on you. Okay. This is the program, and I'm gonna save as a copy so I don't mess it up. That when you run it, you move the arrows and the cat moves around. You can't see me pressing the arrow buttons for obvious reasons, but I'm pressing the arrow buttons and the cat moves around. Okay. So one of the things I ask you to do in the lab is so right now the cat's going by 10 pixels or speed in every direction X and Y for each arrow. That's what all these 10s mean, okay? And remember from high school math, X is like the X-axis of a graph, left and right. Y is the Y-axis of the graph, up and down. So what the lab wants you to do is to go to data, and I already have it, but you would make a variable, you call it speed, and then here it is, okay? And then you have access to this thing called speed, and you can drag it into the number part of the change y by or change x by. And so I want to change y by speed, whatever my speed is. I want to change x by speed, whatever my speed is. And then for the minuses, I have to do -1 times speed, because that's how I'm going to get negative speed. I get -10 here, right? And same thing here, -1, stop that. -1 times speed. And so the idea of a variable is that it's a separate part of the program that can hold a number. You see it up here, okay? Whoa, that was cute. Okay, and the little checkbox here, the checkbox makes it show up or not show up on the screen. I'm of the opinion that showing it is fine, especially because it helps you see what's going on in the thing as you're running it. Now, if I run this, right now speed is 0, so if I press the arrow, you can't tell, but I'm pressing the arrow keys right now, and it's not moving any at all. It's not moving at all because it's changing the y and the x by speed, and speed is 0, so it's changing the y and the x by 0. So one thing we probably should do is right when the flag is clicked, before the forever, we should set it to, I don't know, 10. Okay, and so now when I click the flag, the speed jumps up to 10, and I have access to the arrows moving just like 10. So this is essentially the same program that we had when I started. The cat's moving by 10 when I press all the arrow keys in all 4 directions. It's just moving by 10 because it's moving by whatever is in this speed variable, and that speed variable happens to hold 10. So the other thing the lab asked you to do was to add more cases. So up and down and left and right move the cats, and 2 other keys. I'm going to use, you can use whatever letters you want, or whatever keys you want. Because it helps me remember, use F for faster, and S for slower. And so remember what the reason we have these blocks here, the if block wraps around stuff. You probably, it's almost always, in fact, I think it's always a mistake to have one of these blocks like this hanging out with nothing inside of it, right? Because right now what it says is if the F key is pressed, then do nothing. And do nothing is probably not, it's not useful, right? What I want to do if the F key is pressed, is go faster. And so I want to change the speed by 1, make it bigger every time I press F, or while I'm pressing F. And then if I press the S key, I want to change the speed by -1. Here I can do the minus because it's a number. It's not based on a variable. So if I ever get a hold there, -1, okay? And now when you run this, what happens is the cat starts out at 10, la-di-da-di-da. If I press the F key, it goes up. Now you see how fast that went? I just tapped the F and the S key, and it's going up by huge amounts. And the reason for that is because this forever is forever checking to see if I'm pressing the F or the S key. And every time it sees me pressing it forever, it increases the speed or decreases the speed depending on what I'm pressing. If I press F and S at the same time, it kind of sits still. And so because computers are fast and can go through this forever and check it every single time forever, over and over, forever, really, really super fast, it changes speed by a lot really fast. So the way I fix that is I make it change by maybe 0.01 and -0.01. It's another reason why I have the speed set to 10 when I click the flag, so I can get it started. So let's see this. I tap S. Even that goes pretty fast, up to hundreds and things like that. So all I'm doing is playing around with these numbers, and you want to get into the habit of playing around with things and seeing how it works. 001. Because that's the only way you're going to know what is a reasonable amount. So this is not bad. Pressing faster makes it go. If you tap faster, it goes up. It goes up by a bit. If you think this is still too fast, 0.0001 is a viable option. If I press, so now the speed is 2 point something, and pressing the arrows makes it go slower. Pressing faster for a while, I can get up to 30, and pressing the arrows makes it go a lot faster. If I press speed for a while, it goes negative. Now, if it goes negative, you can't see me do this, but I'm going to press the right arrow. When I press the right arrow, it's going to change the x by the speed, but the speed is -4, so it's going to change the x by -4. So actually pressing the right arrow makes it go left because its speed is negative, so it's like it's going backwards. So just wanted to show you the point of that. And so the idea here is, maybe I'll write this down in the drawing window. The idea here is that where's my pen? Okay. Is that variables in Scratch are used to hold information that changes. Usually things that you want to remember after it's happened. Okay, so I want to remember that the speed is changed and the cat is now should be going at a different speed. Okay, so you use variables as a way to hold stuff you want to remember so you can look at it later when time goes on. So I want to remember that change the speed, and so I want to update the speed. Often you want to what's called initialize a variable to a starting value at the beginning of the script. And so that's what I was doing. Let me go back to the Scratch program. That's what I was doing with this guy here. Making sure the speed is set to a starting value at the beginning before I start checking forever to see if what you did. Okay, so here's something to think about. Here's one script. There's a duplicate button that makes 2 copies. This is having 2 copies of the same script is a bad idea because they're going to interfere. But I just want to show you kind of 2 things side by side. Here are 2 scripts with the exact same lines, okay? The only difference is I put the set speed here on this one and it's up here higher on the other one. What do you think is the difference between these 2 scripts? Right. And what I'm really asking is, what do you think is the difference when I run it? You're telling me the difference is that you put this line here. I know that. I want to know what it means for how the program runs. It won't keep increasing because I set it to 10, right? So what'll happen in the second one is every time I try to change. So let me get rid of this one for a second. I can right click and delete it as well. So suppose this one over here is the only one I've got, right? So so the continuous running will happen anyway, right? But remember, the speed doesn't move the cat unless I'm pressing an arrow, right? So the cat's not going to keep moving when I press it. And the speed's not going to keep changing because it's a set. Set means make it 10, not change it by 10. So what this one does is if I press the flag, it's still sitting here, okay? But if I ever tried, and I can move it around, and that's fine. But if I ever, you can't see me do this, but I am holding down the F key, and while I'm holding it down, it goes up to 10.01, but when I let go, it goes down to 10. Okay, you see how that's changing over there? The reason this is happening is because forever, it sees if I'm pressing the F key. If I am pressing the F key, will change the speed by 0.001, which means the speed will go up to 10.001, but then it goes back to the top. Okay, so what the forever means is do all of these things in this order and then start over. Okay, so once it gets done with checking if the F key is pressed, once it gets done with checking if the S key is pressed, it's going to go back to the top and set the speed back to 10. So essentially what this does is make sure that no matter what I do to press the keys, it'll A, never change the speed by more than 0.01, and B, only change it by 0.01 if I hold it down. And the second I let go, it goes back to 10 because it's forever setting the speed back to 10. Okay? So the point I want to make here is there's a difference between doing something once when I click the flag and doing something or checking something over and over forever. Okay? This is the kind of thing you want to keep straight because there's lots of times this is a thing you need to worry about. For example, in the lab, I think I tell you it's not a bad idea at the beginning to tell the cat to jump to a place like 0, 0. That gets it back on the screen. So if I wander it off the screen and keep on going, resetting and clicking the flag again puts it back to 0, 0 now, and that's nice. But if I was to put the go to 0, 0 inside the forever, then it's going to forever go to 0, 0. And all of the movement I want to do in the world doesn't make it move. And the second I let go of the keys, it bounces back to the middle. Does that make sense? The difference between the stuff in the forever and the stuff before the forever? Stuff before the forever happens once, and stuff in the forever happens forever. And so setting the speed or setting the position to a place forever means it'll essentially never move. Make sense? Okay. The other thing you can do with variables is this is the kind of thing I'm going to make it have. I'm not going to think too hard about the names of these sprites. Click, dang you. Okay. So I got a bear. Look at that big bear. I'm lagging like crazy here. And I'm going to give it another sprite. Maybe the bus. In case you don't know, I think I told this last time, you can click the shrink button to shrink the sprite, or you should be able to click the shrink button to shrink the sprite. And so what I want to do is I want to touch the bus and then touch the bear. And if I touch them in the wrong order, I get yelled at. Okay? So the way I'm going to do that is have a variable. And the variable I'm going to have is going to be, I don't know, bus touched. It's a variable that'll tell me whether or not the bus has been touched. Okay? And at the beginning, taking a, so you can do this by numbers like we do with binary numbers, but I think you can also say no, like the word in there. Okay? So I have this variable called bus touch that starts out as no. Okay? And then if I, for this guy, what I'm going to do is forever see if I'm touching the cat. So forever if, and then in sensing, touching the cat one. Then if I ever touch the cat, then I'm going to set the yes, I touched the bus to yes. Okay. And so right now, all it's going to do is let me move the cat around, la-di-da-da-da. Right now, the bus touched is no. And eventually I hit the bus, and it turns to yes. Okay. What I want to do, and then if I hit the flag over again, it resets to no because I set it to no before the forever. That means you do it once when you click the flag. Okay. In the bear, what I'm going to do is forever see if the cat touches me. So if touching the cat. Now, if I'm touching the cat, I want one of two things to happen. I want to either say hooray if I took the bus and then touched the bear, so I did the bus first. And I want to say no or something if it doesn't. So what I'm going to do is I'm going to use what's called an if-then-else. So the if-then says, if this is true, do this. The if-then-else says, if it's true, do this, but if it's false, do something else. So if I'm touching the cat and I have to go to operators to get my is equal to operator. No, I have things like less than, greater than, and or. So if my bus touched is equal to no, well, equal to yes, then say, I don't know, good job. Else, then the bus touched is not yes. Then I say something like, touch the bus first. Okay. If the bus is touched as yes, then say good job. Else, say touch the bus first. If it's true, do this. Otherwise, do that. And so now when I start this, if I happen to go touch the bear, why is that not working? What's supposed to happen is, there it is. He was saying it off the top of the screen. Touch the bus first, and then I'll go touch the bus, set my bus touched variable to yes, and then I'll go talk to him, and he'll say good job, and that'll be that. Okay. If I do things in the right order the first time, he'll say good job. But if I do things in the wrong order and try to touch him without touching the bus, come on, you flag, then I get yelled at. Okay. So the point is, I'm doing two things. First of all, I'm using this variable to hold a fact about the world that I want to remember for later. I want to remember whether or not I've hit the bus, and the two options are no and yes. Okay. Second of all, I'm using that as a way for the sprites to kind of remember things that have happened. So what's happening is the bear is knowing about whether the bus was touched, even though the bear wasn't involved in the cat touching the bus or not. The second thing I did was I showed you this if-else statement that's like an if-then, but it has a thing you do if you don't do the if-then. Okay, it's a that way you're guaranteed to do one or the other. All right, so using variables to hold this kind of information is useful. Okay, because it lets you remember things that happen, which is often important when you're trying to design stuff. All right. The other thing I want to show you is the idea of broadcasting. Let me screen share my this guy. So the other thing that this shows up in like the second part of the lab, I think. You can broadcast messages between sprites. Messages usually are used as ways to start doing something. And what that means is we have another way. There's a whole lot of ways to start scripts. The most common way is to do it by clicking the green flag. But if you want a script to start later for some reason, then you can make it start on when I receive. Okay. So here's what I'm going to do with this. I'm going to make the bus broadcast a message when it gets touched by the cat. I'm going to make a new message called on the bus. And that's just a name of a message that gets sent around to everybody, and any sprite that wants to listen to it can hear this message. And then this sprite can have a when I receive second thing to do. And so when it receives on the bus, we can make it do something like, say, now come and get me. Okay, so now what happens is both these scripts are running at the same time. This one is running forever. You can kind of see how it's highlighted. This one doesn't start until it gets the on the bus message. And when it does, he says, now come and get me. And when I get that message, I go over and talk to him, and then I get the good job. If I start over and go straight to the bear without touching the bus, I still get that message. And now if I touch the bus, I'll get the now come and get me. And then I'll get the good job. Okay? So it's another way for communication to happen between sprites. Generally speaking, I do I do variables for information that I want to stay around for a while. And I do broadcast for, hey, something just happened, you need to react right away. But you can use any of these. You can use neither of these. I'm not requiring that you use this or not use this in the homework. I'm just trying to give you options for things that that you might realize you want to do something, and so now you're I'm hoping you'll see these as ways to get the thing you want to do done when you get to the homework. Okay. All right. So the other thing I think we ought to do is, now that you've done the lab at least a little bit, hopefully, or you're watching this recording and can stop right now and go do the lab. I want to show you those two scripts that I showed you last time that were a little more complicated, that I made my kids made me write. Just so you can see, again, I think this one's a little too simple for the homework. So what this one does is it has two scripts, one for the black bat, one for the red bat, one for the brown bat. Both of them start when the flag is clicked by going to a spot on the board, 3848, saying "la la 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 lo" for 2 seconds, because my 4-year-old thought that was hysterical. And then forever saying that, moving, seeing if you're touching the other bat. And if you actually, I only have one of the bats saying hello after this. And then if it is, go to an XY that is random. So this pick random picks a random number between here and then goes to that spot. And the reason why the X, the across, goes from minus 240 to 240 and the Y's go from minus 180 to 180 is because I kind of put my mouse on the screen and saw what the biggest and smallest values of the X and Y, this X and Y down here, were. So that's how this works. So when you run it, you got 2 seconds before chaos breaks loose, and they just keep bouncing off each other and moving, and if they're touching each other, going to random places, and then giving you a epileptic fit. Okay, so that's the pick random one. Okay. The other one, the harder one, the more complicated one, was the one with the knight. So let me go back to my stuff and show you that one. So that's this. So this one has a lot of stuff going on. So I want to kind of walk you through the pieces. Again, I don't know that you need to do all these pieces, but if you want to see how something works, here's how it all works. The main sprite is the dragon. Okay. The dragon sprite has a, when the flag is clicked, he goes to minus 203.99, so way over here. That's just the spot. Set its size 50% to make it small, because otherwise the dragon was too big. I have a variable called over, which is the game over variable. I have the stage, which is what board I'm on. Remember, there was 2 boards to this, set to 1. And so, and then I have something that's very close to the arrow, the arrow move program we did for the cat. The only difference is I have this and it's stage 1, okay? Because we're doing slightly different things in stage 1 and stage 2. I have 2 different scripts for stage 1, and then when the 2 key is pressed, we go into stage 2. And so this script kind of stops messing around and responding by letting this only respond if the up arrow key is pressed and it's stage 1. So I walk around, la-di-da-di-da. And so right now I'm pressing arrow keys, and all of these different if conditions are firing based on how I'm moving the dragon around. Okay. If I'm touching sprite 1, sprite 1's the wall, my awesomely drawn wall. The wall shows up when the green flag is clicked. When I get into phase 2, it'll hide. I'll talk about that in a second. If I'm touching sprite 1, I broadcast message 1, which probably is an awful name, but it's the game over message. Okay, so if I touch sprite 1, remember we get the game over message, right? The reason that happens is that this is the game over sprite, and it sits there and doesn't do anything until it receives that broadcast. So this is an example of the broadcast receive mechanic. This sprite only turns on and shows up when it receives that message 1 that gets gotten when the dragon is touching sprite 1. Okay. Other stuff. So then down here we have the check to see if I'm touching the knight. If I'm touching the knight and it's stage 1, then here I am touching the knight. Now remember, I'm only allowed to touch the knight if I'm breathing fire. If I don't breathe the fire, I die. Okay. So this first of all, pressing the space key switching the costume. So inside the dragon sprite, if you look at the costumes up here, the dragon comes with 2 costumes: the sitting around dragon and the breathing fire dragon. And the switch costume command toggles back and forth between those 2 costumes. So spacebar switches the costume to 1B. The S key switches it back to 1A. So if I'm touching the knight and it's stage 1 and my costume number is 2, so you got to look at your list here. Costume 1, see that little 1 in the corner, is the sitting around dragon. Costume number 2 is the fire dragon. Then what I'm going to do is I'm going to broadcast. So if costume is 2, then I broadcast message 2, also badly named. Message 2 is the "Hey, you died" message, and I'll say press 2 to go to the next board. The knight is sitting around. When the flag is clicked, he goes to this spot on the board. He shows himself. He sets the size in half. He points in the right direction because he was facing the wrong way. And he switches his costume to the knight costume because we're going to have knight 2 costume, the "Hey, I'm dead" costume. And then when it receives that message 2, that "Hey, you died," it says "ouch" and switches its costume to the "Hey, I'm dead" costume. So what happens now is that happens because it got this message broadcast. Okay? And so when it gets the message broadcast, it says "ouch," switches its costume to knight 2. Theoretically, so this is not a perfectly debugged game. I'm going to say press 2 to go to the next board while I keep moving around. I will probably say press 2 to go to the next board if I hit a wall and die. Yeah. So, this is not a perfect game. So, now going back to what I had before, if I hit the knight and I'm not in costume 2, then that's my else, and I broadcast message 1, which is the same message 1 as I had up here, which is the "you died" game over message. Okay. So the way I start the second board is I wait till the 2 key is pressed, which means, yes, you can hack the game and just immediately press the 2 key to go to the second board without killing the knight. If I wanted to fix that, I'd probably need a variable that said, "Is the knight really dead?" or something like that to let this stuff happen. And now I'm in this side. Remember, all of this stuff, most of this stuff was waiting for, was having if the arrow key is pressed and it's stage 1. Okay. Here, the up arrow key lights my fire, and the left and right arrow keys work the exact same way. I don't have a down arrow key because I go down by gravity. Okay. So I still have the if up, if left, if right. And the way I do the platform is I made the top of the platform a different color. It's probably a bad idea that it's the same color as the top of the knight's helmet. It probably means that I can land on top of the knight's helmet. You're going to die. Yep. Yeah. But the way I do is I say if my Y position is bigger than minus 144. Minus 144 is my stage 2 is my Y position of what the dragon looks like when he's down here. Okay, I had to do experiments to see what the right spot for it is, because it's where like the middle of the dragon is. So it's not where the top is and the bottom is. But if my Y position is bigger than 144, which is up in the air someplace, and I'm not touching purple, then change Y by minus 3. This is how he falls down by gravity. And then once I'm touching the purple, I stop. And so in the else, if I'm not touching purple, then switch the costume to Dragon 1A. Dragon 1A is the so my kid wanted the fire to be on when I landed here. So I said, if I'm not in this world where this is a confusing else. If my Y position is big and I'm not touching purple, then sync. Else, if I'm not touching purple, which means my Y position is big, but I'm not touching purple because I'm not landed, then switch your costume to the no fire costume. That's how when I sink all the way to the ground, I stop breathing fire. Okay, and then over here I have if I'm touching black. If I'm touching black, then that's touching the spikes on the bottom of these platforms. Okay, these blue things are like the candle holders that hold it on the wall. This is what he wanted. And then if I touch the knight, he still has the door opens. Okay, and then maybe we'll make touching the door. Right now the door sprite I don't think doesn't do anything. Oh, it shows up. When it gets the open door message, it shows up, which is nice. All right, so this is a pretty complicated program, but I want to show it to you so you have an example of variables and broadcasts and different sprites doing different things. This would be a pretty good homework answer. Obviously, don't copy this line by line, but feel free to use parts of this if you want to, if you want to do something similar, or if you want to have these kinds of reactions and things appearing, showing and hiding is a good way to make sprites pop up in front of you. That's a popular thing. So, is there anything you guys want me to show you that you want examples of? That you might want to try to do for the homework, or you try to do in the lab, that you want me to give you an example of so that I can make it for you before you get off and start the homework? Anything? Okay. I do want to encourage you to, I know I tell you always to start things early, but I think especially start this early because you want to, being able to write something big and complicated in this and have it work in one day is probably not going to work. So give yourself time to work on the homework and make it cool, because I like cool things. All right, so I got a little bit of time. So what I'm going to do is I'm going to start a little bit of next week's algorithm stuff, so that way we're not behind in it. It won't be too long, don't worry. So this is next week stuff. So the point of the last week is how to create and analyze algorithms. Okay. Remember, the whole point of computer science is the study of algorithms, which means in a lot of ways the programming part is kind of an afterthought. The algorithm is the interesting solution. So the way I want to have I shown you guys the Price is Right clock game yet? Have we talked about that yet? Okay. So have you guys seen the clock game on the Price is Right? You know what I'm talking about? Okay. You guys need to watch Price is Right, man. So the clock game, the Price is Right is a show where you're trying to guess prices of things. 11 o'clock, CBS. You're the contestant. Here's Drew Carey. He's got his microphone. The wire goes off into the distance. Okay. The host shows an item. The contestant guesses the price. So he shows you, I don't know, a couch, and the contestant guesses the price of the couch. After each guess, the host responds either correct, and you win the prize, higher, which means your price was too low. You bid $5 on that couch, so go higher, is what he's saying. Or you're told lower, which means your price was too high. Okay? The goal is to get the correct price as fast as possible. And in the actual game, there's a clock, and it ticks down, and so you're yelling out fast, hot numbers. He's saying higher or lower over and over and over again until you converge on the correct price and you get it right. Because I don't want to deal with rapid fire talking and things like that. For us, that means in the fewest number of guesses. Okay? So I'm not going to worry about time. I'm going to worry about how many times I have to interact with the host before I get told the right answer. Okay? So we'd like an algorithm, or if you prefer, a strategy that does this. So let me give you a bad algorithm. Okay? Step 1. Guess $1. Step 2. If I'm told correct, I win. Hey, it was $1. Who knew? Step 3. If I'm wrong, I'll have to be told higher. Because the price is always at least $1. It's never free, and it's never negative money, right? Step 4, guess $1 more than your last guess, and go back to step 2. Okay, so I'll guess $2 the next time, and $3 the third time, and $4 the fourth time, and $5 the fifth time. So I'm claiming this is a bad algorithm. So let's focus on why this is bad. Okay. The number one thing to ask is, I'm going to separate the algorithm from the. Does this work? And by work, what I mean is, will this eventually get told correct. No matter what the object is, no matter what the price of it is, if I follow this algorithm strictly, and you guys have a lot of experience now with programs doing things strictly, is this going to eventually get told correct and win me the thing? What do you think? Anybody awake? Oh, sorry, it's hard to, can you get, how about now? Is that better? Am I not sharing the screen? That'd be a bummer. Okay. Can you see the screen at all? Guys, you gotta tell me that. Jeez. All right. So Haley's got it right. Eventually, so yes, it will work because even if this thing was $1 million, right? It will eventually go through a million bids, a million guesses, and get there. But it's probably not a. So question 2, which I think you answered. Is this a good solution? And we'll say not really. Right. It'll work, but it won't work fast enough, is the right way to think about it. This seems like a lot of guesses. Now, here's how we think about this. Suppose the price was X dollars. Okay? How many guesses do we make? So if X is 100, how many guesses do we make? If X is 1,000, how many guesses do we make? So let me rephrase it. If the price is $100, how many guesses do I make? You want the algorithm again? So if the price is $100, how many different guesses do I make? 100, right? I guess $1, $2, $3, $4, up to 100, right? If the price is $1,000, how many guesses do I make? Yeah. So in general, if the price is X dollars, I make X guesses. Or the algorithm takes about X steps. Okay. So here's Sean's bold claim. I can pick a price between $1 and let's say $20,000. It's about the price of a new car, right? In 20 guesses or less. Okay? So this is my bold claim that I have an algorithm in my head that I want to demonstrate for you before we talk about it. That will do this in 20 guesses or less. The crappy algorithm we just did would take possibly 20,000 guesses. Mine will always take 20 guesses. So I need one of you guys to volunteer to be the secret host that thinks up a number and tells me higher or lower and doesn't lie. So any volunteers to be the host? All right. Your job is to think of a number between 1 and 20,000 and answer and tell me higher or lower when I get it. You ready? Okay. Okay. Here we go. Guess one. $10,000. Higher or lower? Or correct. How awesome would that be? Lower. Guess two. $5,000. Higher or lower? Guess three. $2,500. Higher or lower? Higher. Guess four. $3,750. Higher. Guess five. 4,300. Guess six. 40. Oh, I don't know. 650. Guess seven. 4,500. Lower. Guess eight. 4,400. Guess nine. 4,450. Guess 10. 4,425. 4,437. 4,442. That's a new higher than 42. 4,446. I thought you were yupping my answer. All right, lower than that, fine. So 44, 45, 44, 44, 44, 43. It's got to be one of those three. So I'll use my last three guesses, just yell them out. Okay. Cool. So what did I do? Can you kind of see what I was trying to do there with the way I made my guesses? Right. So I didn't start high. I started in the exact middle. Right. So generally speaking, the idea is at the start, I don't know the price, but I know it's somewhere on a number line between 1 and 20,000, right? And I know that if I guess 10,000, you're going to either tell me higher, in which case I chop out everything from 1 to 10,000. I just lost 10,000 possibilities. Or you're going to tell me lower, which means my 10,000 was too high, and I lose those. Okay, and now I'm left with a exact same situation. I have a number line that's the thing I'm looking for is someplace in there. I pick the thing halfway through, and you're going to tell me to chop out half of it one way or the other. Okay, so we'll write this next time. We'll describe the steps next time, but this algorithm always finds the correct price in a few steps. If I really seriously 100% with 100% accuracy can find the middle of every range, I could do 20,000 in like 16 steps. I did 20 because after a while I stopped being able to do it in my head. So there was a point here where I knew it was higher than 2,500 and less than 5,000. So halfway between that is 3,750. I can't do in my head halfway between 3,750 and 5,000, so I just guessed 4,300. So one side ended up being bigger than the other as the math happened, just because I couldn't do the chop the range in half in my head. But it'll always get to the number you're thinking of in a relatively small number of guesses. Remember, our crappy algorithm could take 20,000 guesses, right? So this algorithm is called binary search. Binary because it's two, chopping it into two halves, and search because I'm looking for something. And we'll describe it next week. I just wanted to do a little bit of that so you can see the sort of things we do when we talk about algorithms. In the algorithms week, what I'm going to do is show you lots of different problems like this that are mostly all kind of paper problems or thinking problems, and you come up with steps that are written down to describe it, and then you don't have to worry about programming and hexadecimal numbers and Scratch and all that crap. You just think about the ideas. And so some people like this a lot. Some people think it's too mathy, but it is something that's worth seeing because this is what computer scientists really do under the hood. All right, any questions on this or on anything else? Hopefully you guys are all set to go for this week's Scratch stuff, and then next week's algorithm will be the algorithms week, and that'll be the last week of the semester. So as always, send me emails if you have questions. Earlier is better, so I can answer your questions and help you with more time to get it done on time. If you have trouble thinking about cool ideas for your program or for your homework, or you want me to tell you whether I think your cool idea is cool enough or too cool, let me know, and I will give you my opinion. All right, see you guys next week. I will shut this off. See ya.